All right, this is still in chapter 40, feedback and homeostasis. So animals can be put in two categories, either regulators or conformers. Regulators use internal mechanisms to control internal change in the face of external fertilization. So you're going to have a more consistent temperature. In this case, it can be other factors instead of temperature. So a regulator is like the sea otter, whereas conformers allow their internal conditions to change in accordance with changes in the external environment. So conformers are like this largemouth bass. Spider crabs are a conformer to salt concentration. Homeostasis is maintaining an internal balance. In humans, we have a body temperature of about 37 degrees Celsius. Blood pH is 7.4 plus or minus 0.1. And blood glucose levels should be between, try it over here, 70 to 110 milligrams per 100 milligrams of glucose per 100 mils of blood. Now, there's a term called dynamic equilibrium, and that results from changing external conditions and internal mechanisms that control those changes. So this isn't like, oh, I fixed it, okay, we're good forever. If the outside is always changing, the inside is always trying to work to oppose that change, to keep you the same. So, mechanisms. Your non-living example is a thermostat in a house. You set whatever you want room temperature to be, and if it increases, then if it gets above 20, the heat's going to stop. It's not going to continually heat the house. If it drops below 20, the heat will kick on. But you have to have some sort of set point. And this is just if you have any derivation from that set point. That's going to be the stimulus detected by a sensor receptor that's going to go to the control center and result in a response by physiological activity that helps to return to that set point. Feedback, you're going to have two types of systems here, positive and negative. And the thermostat situation we just talked about is negative feedback system. And most of your feedback systems are negative. That's the most common. It reduces the stimulus. For instance, if you exercise, you will increase your body's temperature, which your nervous system triggers you to start sweating, and then the evaporation of that sweat cools your body to the set point. In positive feedback systems, this is going to amplify the stimulus. And it's not used for homeostasis. This is homeostasis. This is used to drive a process to completion. Your main example here, let's make that an I, is birth. During childbirth, the pressure of the baby's head against receptors near the opening of the uterus stimulates the uterus to contract, which causes greater pressure, which causes more contractions and greater pressure until the baby's born. Alterations, regulated changes occur in your body like puberty, and there's a radical shift in hormones. In a woman's menstruation, there's a cyclic change. Your biological clock, the circadian rhythm, that's for boys and girls, this is not about having babies. Circadian rhythm is also cyclic. It's in animals and plants, and it's changes that take place in approximately 24-hour cycles, normally associated with hours of light and dark. Melatonin is a chemical that is secreted at night, and because night is longer during the winter, more is secreted in the winter. Your circadian rhythm or biological clock can be reset, but it takes time. That's why there's, they call it jet lag. If you travel more than a couple of time zones away from home, it takes you a little while to catch up and reset your clock. You can see here some of the cycles that happen in 24 hours in humans. There's also something called acclimatization. And this is a change in homeostasis. It's a gradual change that an animal adjusts to in the environment. This is like if you move, or an elk moves from sea level up to the mountains. When you first make that move, you're going to breathe rapidly and deeply. You're going to lose more CO2. In elk, there's a change in kidney function to make the urine more alkaline, which then returns blood pH to a normal range, which increases RBCs that carry oxygen to accommodate for there being less oxygen in the air. This is a temporary change, though, not an adaptation. An adaptation would require a change in a population that results from natural selection over many generations. So this is just temporary change.